Tibal will introduce it.
Okay. Next talk is presented by Lim, and it's about completing proofs, auto-completing proofs. Go ahead, please.
Yeah, thank you for introduction. So, yeah, I'm Jing Lim, a final year PhD student from Singapore University of Technology and Design, SUTD. So the title of my talk today is Auto-Complete Disproof, Decentralized Proof Generation via Smart Contracts. This is a joint work together with Barnabé Monnot from Ethereum Foundation, Georgios Piliouras from SUTD as well, and Shaowei. Okay, so I'll first share with you the recent update in formalized mathematics. So in the recent article in Quantum magazine, so there's an article that states that proof assistant makes jump in big league math. So what is it about? So mathematician has used Lean, the proof assistant, to verify the accuracy of a difficult theorem at the cutting edge of research mathematics. So it's a new mathematics. So what is this about? So it's a piece of larger project called condensed mathematics. So it was initially thought that it will spend around 2 years to formalize this whole thing, but in the end, in a matter of 6 months or 6 months plus, okay, then the whole formalization is complete. So now, why is this possible? So at first, a public statement is made in the Kevin Bowser blog that state all the theorems and all the proofs that are required to be formalized, and it called the liquid tensor experiment. So in the end, it is a big collaboration, okay, with a lot of people doing what they are good at, then eventually make this like eventually from 2 years period cut down to 6 months. So what did we learn from this? So the importance of having a top-down approach where someone can state his or her problem statement, and it is then broken down into smaller parts for contributors to prove. The importance of dissemination of partial results and problems. And lastly, the importance of collaboration between mathematicians and computer scientists. So now we question ourselves. Now, what is a good way for someone to post his or her problem statement formally and allow contributors to work on it together and also have an end goal in mind? For dissemination of partial result, what is a good platform where contributors can post their partial result and state their problem and always get the update almost immediately? And lastly, for the contribution part, suppose we have a contribution, how can we assign, verify authorship to each of the partial result, and how can incentivize and allocate rewards, if there's any, fairly to the contributors? So these are the questions we ask ourselves as our research objective. So our proposed solution is blockchain your own partial proof. So over here, we'll use blockchain as the platform such that someone like prover A can have a top-down approach to state their problem. Then any prover B, C, and D, whenever there's a partial result, he can post the result in this formalized proof, okay, and disseminate all these results to everyone else. And lastly, through this platform, we have a collaboration between all these provers that we have a common problem. Someone said the problem, then we solve it all together as a collaboration. We also hope that eventually AI system, so automated system, will come in and contribute and help to, so like a human AI collaboration to solve common problems together. So before I proceed, let's make sure everyone has a common understanding what's a blockchain before I continue. So I'm just going to give a very, very short introduction of what is a blockchain. So a blockchain can be thought of as a decentralized book of records. This book of records is just one and only and universal. However, all users will have a copy of it. So over here, every message you write down or every record that you've written down in this book is timestamped and can be signed off by the author itself. Okay. However, all these messages can be from anyone and is immutable. So as a result, all this signature will be encrypted and is verifiable. So what I display over here is like an application in finance where the messages are transaction between user. So there are other applications like healthcare where the messages are the patient private information. food, which is the food supply chain, where the food, where have it gone from where to where. So what we want it to be is a decentralized book of formalized proof, where the messages are partial proof leading to bigger proof to solve a common problem together. So why we believe that blockchain is good? There are advantages such as decentralization, timestamp verification, and programmable credit assignment via smart contract that can be used by this blockchain technology. So to elaborate a bit more why blockchain, so decentralization allows fast dissemination of partial result and problems. As a result, then we have an emergence of common knowledge within this community of formalized mathematics. The timestamp verification allows authorship of partial progresses from distributed collaborators to be verified. And lastly, with the help of smart contract, we can have credit assignment that gamify this whole system, all this process of formalizing mathematics to incentivize provers to post their partial result. So if all this happens, we can have a new token. For example, we call it a for-math token, which represent short form for formalized mathematics, or you can think of it as for the love of math. Okay, can be used to measure the contribution to formalized mathematics. So because of all these benefits and stuff, there are some prior works that try to look at how we can implement this on the blockchain itself. So there's QDDAS, MathCoin, and ProofGo. However, what differentiates us from the rest is we want to add in a collaborative element via smart contract, where people can put in a partial result and will be rewarded via some incentive mechanism by the client who posted the problem itself. So in the overview, our system architecture can be broken down into 3 different layers. So data layer, which describe what is recorded. Client layer, we describe what is meaningful. And incentive layer to describe what will be rewarded. Okay, so we'll go into each of these layers one at a time. So for each of the files, so for example, be it Cobb or be it Isabel or be it Lin, okay, we believe that the file that you have generated when you return your formalized proof will be stored in some decentralized file system network, for example, IPFS. And from there, they will generate a hash address. Okay, it's like the location of where have you store your file in. Okay, so after you record it on the blockchain, so the record must minimally contain the prover address. So eventually, when we have an incentive mechanism, we want to reward the person, we can know who to reward to. The prover address, the IPFS hash address of the contribution means your file, this hash address, all the import references, and the contribution type. So like, are you posting a conjecture? Are you posting a partial proof? Are you posting a tactic or anything? So one layer up, the client layer. So at this layer, user or provers can access and download records and contribution. You will have an interface to present a string diagram or directed acyclic graph that built by the imports declared, so that someone will know, okay, how have the proof has been progressed until now. And a plugin to the chosen proof assistant editor may be built so that whenever you want to perform any validity checks that cannot be handled by the data layer, it can be done. And the most important layer of which, that differentiates us from the rest is the incentive layer. This is where we can deploy incentive mechanism via smart contracts. Okay, so either we can reward one sole prover via the voting for main contributor, or split the reward via some allocation rule. So there are some. So if you want to split the reward, who is the main contributor, you need to score the contribution accordingly. So there are different approaches that we can take a look at. So for example, one of them is TCR, Token Curated Registry, where it's incentivized participants to vote and rank the importance of the contribution. So without further ado, I'll just illustrate using an example on how a sort program can be, the proof of a sort program can be generated in Coq via this system itself. So for example, as some client, okay, that come up with this ct00.d, a Coq file. Okay, so it posts a conjecture or sort program for all these L, that is L prime such that is sorted and the permutation of original list. So when this client posts this COG file. Okay, what's happening in the data layer? So over here, the COG file will be saved, stored in some location over here, the decentralized file system. They will give a hash address. So in the blockchain itself, it minimally must record the approval address, the contribution address, and the hash address of all the imports accordingly. Okay, we assume that all these imports, all the like standard library have been stored in some location in this decentralized file system already. Okay, and the contribution type for this type is a conjecture type. So in the client layer, what would the client or other user would see is that a string diagram representation of what is currently being built on. So we'll use H to represent type, solid node to represent completed proof term, and dotted node to represent incomplete proof term. So over here, from all the imports, then we have this proof term or this file CT00 contribution to be exact, okay, contribution that will lead to this type sort proc. So this is dotted because the proof of this sort proc is not being proven. So there's a dotted proof term over here, incomplete proof term that lead. So eventually you want all these dotted proof term that leading from whatever type it is to the true to be completed. So at the incentive layer, the client can implement a smart contract, something like this. Okay, like for example, you verify if the program has been true, like for example, it's proven already. If the number of prover is just one only, you just transfer everything, 10 tokens to the prover. If there is more than one else, then you do some allocation rule to distribute the 10 tokens. So after this first CT00 contribution 00 has been posted, so someone has been notified, oh, okay, some prover A, so a human prover, decided that, okay, I want to try to put a partial proof. Okay, so this is where the benefit of having a proof assistant comes in, because proof assistant allows us to post proof with gaps, which over here I term it as partial proof. So here, proof A believe that by using induction, it is the way to go, and he keep the base case and inductive case proof empty and use it over here as the partial contribution or partial proof. So when this happens, the string diagram going to get updated, okay, to CT01 to replace by the dotted node and branch out to two type, okay, sort base and the sort base inductive case, okay, where these two will lead to two dotted circle because it's incomplete proof. So this is where AI system can come to contribute as in this illustrative example. So as of now, CT00 and CT01, there's three so-called conjecture out there. So it's the original sort proc, the base case, and the inductive case. So for example, some user that use CogHammer or the CogHammer or developer go and look through all these conjecture. Okay, then go and try to automate this. Okay, this one they fail. Okay, this one succeed. And okay, then lastly, the inductive case, you also cannot hammer through. Okay, so what happened in the client layer? So everyone, once this is posted, okay, you see that it's again updated. Okay, for here, I'll use a green node to represent AI system. Okay, so yeah, so this is where the contribution of AI can come in, and this eventually this CT02 lead to the proof of sort base. So the base case of the sorting algorithm. So eventually, right, as this go on and on, then all of this partial proof will get completed. So because the initial proof is started by using inductions, so you have an insertion short proof, okay, from this human AI collaboration. Okay, so the client layer will see this, and when this is achieved, okay, the smart contract gonna get activated. Okay, then when this happens, okay, then it will get distributed accordingly. For example, here there's 10 token over here, then it will distribute accordingly to depending on the allocation rule. Here over here, the bigger coin means more proportion of the 10 token that you're gonna get. For example, this is the case.
Yeah,
so yeah, sorry.
You have 4 minutes.
Okay. So same proof but different. Same theorem but different proof. So what do I mean by this? So we know that COG allows us, or proof hasn't allow us to formalize or create new tactic. So over here, what I've done is to formalize the divide and conquer algorithm paradigm. Okay, then from here, instead of using the induction, okay, some other user believe that, okay, maybe we can use this divide and conquer to go about and prove this. Okay, so instead of having base case and inductive case, you get base case, one element case, and the inductive case. So what we're trying to do is that, so instead of having, in terms of math, right, usually we okay with just one proof itself, but it's now, if we are building a proof for programs, then sometimes we want different ways of proving it. For example, in sorting, we have different efficiency and stuff. So this is what we wish to have, is have a decentralized way to build different proofs collaboratively. So for example, from just now, that CT05 will get 3 different, and eventually we'll get all these different proofs accordingly. So to conclude, the challenge is to have humans and AI systems to collaborate in formalized mathematics. So in the last iteration of AITP, Prof. Paulson mentioned that the importance of proofs with gaps, and there's already a trend towards incremental proof construction instead of full proof automation. So our solution is that to use blockchain as a platform to unite collaborators together. So we hope that eventually, as more and more AI systems that work on incremental proof assistance, it will work together as a unified proof or program synthesis. Okay, so for example, the sub program, for the past few days, when we have seen many very amazing work by Yutaka and Albert, Jiang, Lisa. So for example, this can pass, so we have some problem, it will pass to one AI system to try to solve some partial proof, and pass to another one, then continue and finally pass to Sledgehammer or whatsoever, they eventually solve the whole proof. So we'll use this as a platform to work as a unified proof and program synthesizer. So the future direction is that because what are the ways to allocate rewards, if there's any, fairly to contribution within the same proof and across different proofs, and the ways to incentivize creation of new mathematical objects such as definition or tactics, for example, just now divide and conquer, because the divide and conquer can be used other than using in sort prop, you can use for other to prove other property for this. And what about completed proposition? Yeah, so with that, yeah, thank you for listening. We would like to have any question or any feedback. Thank you.
Thank you very much. We probably have time with one very short question.
Oh, I can do a quick one. So how do you, it doesn't, I'm not sure whether you are sort of doing the proof checking in the blockchain or outside of the blockchain, and like, is this an issue? Is it not an issue? Like, how do you make sure that when somebody says he finished a proof, it's really a proof?
Okay, so I think there's 2 different type of ways to go. One is to have the blockchain system to check all the proof, but then it would take a lot of it's not efficient at all. So then you will run a lot of electricity for everyone. If suppose you deploy to everyone, then everyone need to check. It's not effective. That's why we believe that we need to store the file at some decentralized file system, and to verify. So to verify a proof, right? We can have either the client layer, okay, to check whether. So this is one of the problems that we are still trying to so-called tackle. So it's either we use the whoever at the client layer, the user, will need to own self go and check the proof itself. Okay, but we have other ways, such as there's I think called zero knowledge proof, where instead of showing that the file exists, we show that, okay, the file really compound to what it is. So the proof is already been verified and stuff. Then you can use it as evidence and store it in IPFS address instead of the original file itself, or both of them to be stored. So yeah, so this is a sort of a difficult problem there, but we are looking at ways to solve it.
Thank you.
Yeah, no problem. Thank you for the question.
Yeah, so thank you again for this very nice presentation about blockchain and Ethereum domain.
Thank you.